So good afternoon, everyone. Today we're going to discuss section 10.5, which is partial fraction composition. Okay, so please follow along and take notes with me right now. Okay. Now, let me share the desktop and let's get started. All right. So 10.5 is partial fraction decomposition. Okay, so the goal is to actually later on in calculus class, so in calculus 2, what we will do is, for example, take an integral of 5x minus 1 over x squared plus x minus 12. Okay, so dx. And what we need to do next is rewrite these 5x minus 1 over x squared plus x minus 12 into two integrals. So 5x minus 1 divided by x squared plus 4x plus x, minus 12. This is actually, later on, you'll know this is 3 over x plus 4 plus 4 over x plus 3. And then we will take the integral with respect to the x of each one of the terms. So this process of writing 5x minus 1 divided by x squared minus x plus x minus 12 into these two expressions is called partial fraction decomposition. So it is used later on in calculus 2. Okay. Now, so there are 4 cases of partial fraction decomposition. So 4 cases. So case 1. Alright, so this is P over Q. So we want to do a partial fraction on P over Q. Yeah, P of x over Q of x. So P of x is the numerator, Q of x is the denominator. So case 1, Q has non-repeated linear factors. So non-repeated linear factors. Yeah. So or Q of x can be written as x minus a1, x minus a2, etc. Yeah, until x minus an. But not, these are all linears and non-repeated. Okay, so for example, write the partial fraction decomposition for, alright, so number 1, x squared, x, on top is x, divided by x squared minus 5x plus 6 is equal to, for x over x squared minus 5x plus 6. Alright. Now, so what we do first is we will factor out x squared minus 5x plus 6. So this is x over x minus 3 times x minus 2, right? So now this is linear and non-repeated. So if it is linear, we have a constant on top. So x minus 3 plus b over x minus 2. So this is linear, and the term that we put in the numerator is 1 degree less than the linear term. So this is 0 degree. 0 degree means constant. Okay. So now there are two methods. So what we do here first is to cancel the common denominator. Yeah. So we will multiply by the LCD. So the LCD, let me write it again. Okay. So, excuse me. Let me see, am I recording? Hold on. Yes, I'm recording. Alright, so let me write it again. This is x over x minus 3 times x minus 2, right, is equal to a over x minus 3 plus b over x minus 2. Now what we want to do first is eliminate the denominator. So we multiply both sides by the LCD, which is x minus 3 times x minus 2. So here this is x minus 3 times x minus 2. So here x minus 3 times x minus 2. Right. So these two cancel. Right? And then x minus 3 and here x minus 2. So what are we left with? So x is equal to a times x minus 2 plus b times x minus 3. So now we don't have the denominator anymore, and we could choose what method we want to use. So I'm going to write down method 1 is choose x values. So choose x values. Of course you want to choose so that it's easy to solve for a and b. So a and b are constant, are numbers. And I want to choose x such that it is easy to solve for a and b. Now this is my equation here after the denominator is gone, is eliminated. Now let's see here. If we choose x equals 2, then this will be 0. So 2 minus 2 is 0. And then a will be gone, so I could solve for b. Right? Now if we choose x equals 3, then 3 minus 3 will be 0. Then I could solve for a. So it's not hard. So let's choose x equals to 2. When x is equal to 2, the left-hand side is 2 is equal to a times 2 minus 2, well, 2 minus 2 is 0, plus b times 2 minus 3. Alright. So 2 is equal to, well, 2 minus 2 is 0, so these all go to 0. Yeah. Minus negative b. So b times negative 1 is negative b, so b is equals to negative 2. Alright, so we made a good choice for x because we eliminated one variable, so it's easy to solve for b. Now the other thing is we could choose one more, x equals to 3. So the left hand side will be 3 is equal to a times, so maybe I should do this, okay? So 3 is equal to a times 3 minus 2 plus b times 3 minus 3. Well, 3 minus 3 is 0. 0 times b is 0. So this is 3 is equal to a, right? Alright, so we solve for a and b. Then we have to write down the answer. So the answer is a over x minus 3. So 3 over x minus 3 plus b, so plus b is minus 2 divided by x minus 2. Yeah. So that is method 1. Okay. So choose x. Yeah, so we want to choose x so that if possible we eliminate one variable. So if possible we choose x in which we eliminate one variable. Okay. Now, the method 2 is distribute and collect like terms. So I'm going to copy this, okay? So I'm going to copy this and then do the problem on the second page, on the next page. Yeah. Edit. Okay, let's see here. Edit. Copy. Okay. So we're going to do it using method 2. So you know which method to use. Yeah. You could actually choose the first method 1 or method 2, depending, or sometimes both method 1 and method 2. Sometimes one method is easier than the other. Sometimes you just need to use the combination of both, etc. But we need to know both method 1 and method 2. So method 2 is we distribute and collect like terms, and then we compare left and right. Okay. Alright, so here I am going to distribute the right hand side. So this is ax minus 2a, right, plus bx minus 3b. So this will be x times, well, I am going to collect the x and I am going to collect the constant. So the constant is negative 2a minus 3b. The x is a plus b, so ax plus bx. Yeah. Now, here we will compare, so distribute and collect like terms. Maybe I should say compare with the right hand side. So compare with the right hand side. Oh, I have to copy these two. Sorry. Bring here. Okay. So distribute and collect like terms and then compare the coefficients on the left with the ones on the right. And then we have some equations. Now look at this. This is x, okay? And this is x. Now, since left and right side are equal, then the coefficients of x here should be equal to the coefficient of x on the left. So what is the coefficient of x on the left? 1, yes. So what is the coefficient of x on the right? A plus b. So my first equation is a plus b is equal to 1. So this is an invisible 1 here. Okay. Now, what about my second equation? Well, where is the constant? What is the constant on the left? Well, there's none, so this is actually 0. And what is the constant on the right? It is negative 2a minus 3b. So your second equation is negative 2a minus 3b is equal to 0. So this is a 2 by 2 system, which we could easily solve using elimination or substitution. Yeah. And after we solve, then we should get a is equal to 3 and b is equal to negative 2. Just like what we got on the first, using the first method. Yeah. So, but I'd like you to understand is that we distribute the a and the b, okay, and the other one is compare the coefficients on the left with the ones on the right. So we end up having 2 or more equations. Yeah. So here I have x term here on the left and on the right. So a plus b, the coefficient of x on the right, is equal to the coefficient of x on the left. So a plus b is equal to 1. And then what about the constant? There is none here, so 0. So I have a constant on the right, so this constant must equal to 0. Okay, and then we solve using elimination or substitution. Yeah, so we're not done here. Okay. Now, anyway, we could finish it, and then you'll see that it's the same problem. So let's eliminate a. Yeah, we use elimination, or you could choose substitution. So equation 1, we will multiply by, this is negative 2a, so multiply by 2. Okay, so we have 2a plus 2b is equal to 2. Now equation 2, we will just copy. So negative 2a minus 3b is 0. So here we have negative b is equal to 2, so b is equal to 2. Negative 2, okay? So b is negative 2. So same as the answer we got from the first method. Now what about a? So substitute b equals negative 2 to the first equation. So I'm pretty sure we will end up with the same answer. So when we substitute, we have a minus 2 is equal to 1. And then add to both sides, a is equal to 3. Alright. So again, your answer will be 3 over x minus 3 minus 2 over x minus 2. So same as the previous method. Okay, so can you use either method? Yes. You can also use the combination of method 1 and method 2. Yeah, because sometimes you start with method 1 and then it's harder, so you end up with using method 2. Yeah, good. So we did the first case, which is non-repeated linear factors. Yeah, for q of x. q of x is the denominator. Alright, now let's do case 2, which is linear factors, some of which are repeated. Yeah. Okay, so I think we will use the next page. Or let me see. We could use this page actually. And then we will continue on the next page. Yeah. So case 2. So did we label this as B? Hold on, let me go back. Oh yeah, so this is A. This is case 1. Q has non-repeated linear factors. Okay. Now the next one is case 2. B. Case 2. Now Q of x, the denominator, has a linear factor, some of which are repeated. So some of which are repeated. Yeah. So we're going to do partial fraction decomposition of this problem. X squared over, let me see, what is it? What it is? X minus 2 squared times x plus 1. Yes. So x squared divided by x minus 2 squared over x plus 1. Alright. So let's see here. So these two factors are linear. So x minus 2 is linear. It's just that it's repeated. And x plus 1 is linear also. It's just that it is not repeated. Oh yeah, x plus 1 is not repeated. So only x minus 2 is repeated. So they're linear. It's let's repeat x minus 2. So since they're all linear, then on top I will put 1 degree less, so it's a constant. So if we have terms that are repeated, linear, I'm going to repeat this. So the first one without the square, and the second one with the square. If this were a 3, x minus 2 cubed, then you have to have x minus 2 square, and x minus 2 cubed, right? So I was just saying, if this were cube instead of a 2 is 3 instead of a 2, then we will repeat it 3 times. X minus 2, x minus 2 square, x minus 2 cube. Now on top, since this is linear, we will write 1 degree lower. So it is constant. So constant is, the first constant is A, B, and the last one is C. But they're all should be constant. 1 degree less than your factor, your linear factor. Okay? Now, what we need to do next is clear the fractions. So multiply by the LCD. Alright, so in this case maybe I need more space here, but I'm just going to squeeze them in. X minus 2 squared times x plus 1. So both sides we will multiply by x minus 2 squared times x plus 1. I think it's a little small. Let me think. Maybe I will do it on the other page. Hold on, okay? I'm going to have to copy this and redo this on a different page, because otherwise it's too small. Okay, I am so sorry. Paste. Alright. Now, I'm going to rewrite this first. Yeah. So, A over x minus 2, and I'm going to give space for the multiplication. Okay. Times B over x minus 2 squared plus C over x plus 1. Okay. Now, the A, we have x minus 2 squared times x plus 1. So the B is x minus 2 squared times x plus 1. And the C is x minus 2 squared times x plus 1. Okay. Now, I could write them like as just one on the left and one on the right, and then we will multiply each one. But I guess, sorry, my screen is a little dirty. Hold on. Yeah, I was just cleaning it. Sorry. Now, now I could just write ones, but I think it is easier to understand if we write if we multiply to each term instead of just writing one on the left and writing one on the right. So it's better if we write it to each term, so it's easier to see. Yes, it's easier to see which ones to cross. So x squared here is equal to, well, I am crossing x minus 2, but I still have one x minus 2 on top. A x minus 2 x plus 1. Okay. Plus B, now I'm crossing the x minus 2 squared times x plus 1, plus C, the C is I'm crossing out x plus 1. Okay? Good. Now, this is what I have so far. We could choose either method 1, C times x minus 2 squared. It's missing x minus 2 squared. We could choose to choose x. So method 1, choose x. So, and then, or we could use method 2. So let's try method 1 first, and then if it doesn't work, then we could try method 2, or we could use some parts of method 1 and then use method 2 also. Yeah. But let's choose method 1. Now let's see. We have to be strategic about choosing the value of x. So let's see here. If I choose x equals to 2, then this is 0, and this is 0. Oh, so I'm going to get B. So why don't we do that? So this is our own choice. Let's choose x equals to 2. So now the left-hand side is x squared. So 2 squared is equal to, well, this is A times, well, this is going to be 0 anyway, right? 2 minus 2 is 0. Plus B times 2 plus 1, so x is 2, plus C times, well, 2 minus 2 will be 0. So 2 squared, that is 4, is equal to 3B. So divide both sides by 3, B is 4 over 3. Yes. So is it okay to get a fraction? Yes, it is perfectly fine to have a fraction. Yeah. Now, what about when x is equal to -1? Okay. So then this will be 0, and this will be 0 also, so I could solve for C. Good. Now, when x is -1, look at this. This is -1 square, so 1. So -1 square is equal to a, well, if I substitute -1 here, this will be 0 also, plus b, oh, -1, so this will be 0, plus c times -1 minus 2 square. Yeah? So -1 square is 1 is equal to 0 plus 0. What about this? -3 square. -3 square is positive 9. Yeah? So 9c, divide both sides by 9. C is 1 over 9. All right. So how are we going to solve for A then? Well, I mean, we already solved for B and C. So what we could do is we could just pick any x value. So continue with method 1 and pick any x value. And we also could substitute B and C here. Yeah. So here x equals 0. This is easy also. Yeah. On the left, so 0 square is 0, is equal to a times -2 times 1. So I'm substituting 0 minus 2, 0 plus 1, plus b. We know b is 4/3 times 0 plus 1. So 0 plus 1 is 1. Plus c times x minus 2 squared. So practically I'm using this equation right here. Yeah, for each one of my equations. So 4/3, and then the c is 1 over 9. So I'm substituting the c here, 1 over 9 times -2 squared. 0 minus 2 is -2. So 0 is -2a plus 4/3, and this is plus 4 over 9. Okay? So then if we don't want to deal with fractions, we will clear the fractions again. Multiply by the LCD. LCD is 9. So 9 times 0, 9 multiplied by -2a, 9 times 4 over 3, 9 times 4 over 9. Okay, so that is the LCD. So 9 and 3 cancel, so this is 3 and 9 cancel. So we have 9 times 0, that is 0, is equal to -18a plus 3 times 4, which is 12, plus the 9 cancel, so plus 4. So 18a is equal to 16. So divide both sides by 18a is 16 over 18. Well, we have to reduce this. They're both divisible by 2. So divisible by 2, 16 divided by 2 is 8. 18 divided by 2 is 9. So a is 8 over 9. Yeah. Okay, so now I know my A, my B, and my C, right? So I'm just going to write the answer. My A is, so A over x minus 2. A is 8 over 9. So I'm going to write it like this, and then I'm going to write another one. 8 over 9 over x minus 2 plus B. B is 4 over 3 divided by, let's see, what is this? X minus 2 squared plus C over x plus 1. So C is 1 over 9 over x plus 1. So, or I could write these, because this is a complex fractions, right? So I can write it like this. 8 over 9 times x minus 2 plus 4 over 3 times x minus 2 squared plus 1 over 9 times x plus 1. Yeah, so these answers are good enough. So either we could use the top or the bottom one. It's up to us. Yeah. Okay. So All right, so now we did case 2, which is, let's see, case 2 is what? Q of x contains linear factors, some of which are repeated. So you see the x minus 2 here is repeated. Why? Because it's x minus 2 and x minus 2 squared. Okay? All right. Good. So now we're done with linear factors. The next two cases talk about quadratic factors. So, by the way, if you have a factor for, okay, let's just practice writing it, okay? So let's just say I'm just making it up, okay? So 5 over x squared times x minus 1 squared times x plus 2. So this is a different problem. We were done with the problem that we previously did. Now we're just going to write it in terms of A, B, C. But let's see, all these factors are linear, but the x is repeated, and the x minus 1 is also repeated. So I'm going to have x, and I'm going to have x squared, and I'm going to have x minus 1, and I'm going to have x minus 1 squared, and the last one is just x plus 2. Okay? So what goes on top of x? So it's just a. It is linear, remember? So the degree of the numerator will be 1 fewer. Yeah, 1 less degree. So here there's no degree. Degree 0, meaning constant. So same thing here. These are all linear. It's just that it is repeated. All right? No, we're not going to solve it. But that's what I mean. So whatever is repeated, you have to repeat twice. Whatever has exponent more than 1, we have to repeat it. Yeah. If this were 3, x cubed, then you'll do x plus x squared plus something over x cubed also. Yeah. All right. So good. And remember, x squared like this is linear but repeated. It's not quadratic. This is not considered quadratic. It's linear and repeated. Okay? All right, so next is case 3. So case 3. Okay, let's see. What is case 3? Q of x contains quadratic factors but not repeated. Quadratic. Let me write down. Q of x contains quadratic factors but not repeated. Okay? So, for example, we have 3x minus 5 divided by x cubed minus 1. Okay. All right. Now, here you have to remember how to factor x cubed minus 1. Yeah. So x cubed minus 1, we will use these two formulas. I hope you remember. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. Okay? So if this is sum of cubes, the a plus this, you will have a plus b. And if you have a cubed minus b cubed, we will have a minus b. And then a squared plus ab plus b squared. Okay? So if this is the sum, then a plus b, and this is minus. If it's a cubed minus b cubed, the difference of two cubes, then the binomial is a minus b, and the trinomial is plus, consists of plus. Okay? Now this is x cubed minus 1, so I'm going to use this formula, the second formula. When I factor this, this is going to be, let me see, what is it? It's going to be x minus 1, right? Multiplied by x squared plus so x minus 1 a minus b times a squared plus ab. Ab is x plus b, yeah, b squared, sorry. So 1 -1 squared is plus 1. So, well, so this is 3x minus 5. Okay. Now let's look at these. Yeah. Probably I have to write it a little bit bigger. So this is linear. Okay. So this is linear. So on top, I will just have a constant, 1 degree fewer, 1 degree less. Yeah. And the bottom, I have x squared plus x plus 1. So in this case, this is quadratic, right? Okay. So I'm going to write bx plus c. So 1 degree less, then you will have a something that consists of x, so linear, and a constant. So you have to notice the difference between these two. Why did I put, instead of b here, I wrote bx plus c? Well, because this is quadratic, non-repeated, yeah? And if it is quadratic, then you will have something on top, on the numerator, which is linear, which is 1 degree less or 1 degree fewer than the one in the denominator. So if this were x cubed, then we will write bx squared plus cx plus d. Yeah? So it has to be 1 degree less for the numerator. Okay? So if this were x to the 4th power instead of x squared, then you'll have bx cubed plus cx squared plus dx plus e. So aren't you glad it didn't happen? Okay, we only have x squared. Okay. Now what we want to do is clear the fractions. So we will multiply with the LCD. So the LCD, well, it's just this one, x minus 1 times x squared plus x plus 1. So here, same thing, x minus 1 times x squared plus x plus 1. And here, the same thing, this is x minus 1 times x squared plus x plus 1. All right. Yeah. Okay, so cancel common terms. All right, so here, x minus 1 cancel, and here, x squared plus x plus 1 cancel. Yeah, so I'm not including this one. Okay, so we will think that they're separate. I'm starting with this right one. Yeah, so we're sort of ignoring the first part. Okay. Now on the left we have 3x minus 5 left, and on the right we have a times x squared plus x plus 1. Plus, oops, this is the plus. It is covered by the what is it? Common factor. So plus bx plus c times x minus 1. Okay, so we could use either method 1 or method 2. So method 1, we choose x. Okay. All right. So let's just choose x. So method 1, we choose x. Method 2 is we will distribute and equate the right-hand side with the left-hand side. So method 1, we choose x. Yeah. Let's see here. Well, there's no x, that makes it 0. So how about here? Maybe 1. X equals 1. That's good enough. Yeah. So x equals 1. Now this left side becomes 3 minus 5. 3 minus 5 is negative 2. Is a times 1 plus 1 plus 1. Plus, oh, this will be 0. Bx plus c. B plus c times 1 minus 1 is 0. So we could ignore this. Negative 2 is equal to 3a. So a is negative 2 over 3. Done with a. All right. Now, what about the b and c? Yeah. Well, if you want to stick with method 1, then even though it doesn't make it 0, you could just find any other numbers. So maybe choose two more numbers. When x is equal to 0, it's always easy to calculate. So the left-hand side, this one, so I'm looking at this one right here, okay? This one, 3x minus 5, yeah? So when x is 0, 3x minus 5 becomes negative 5 only. So a times, well, 0 plus 0 plus 1, so a times 1 plus b, oh, b times 0, oh, that's going to be 0. B times 0, okay, plus c times 0 minus 1 is negative 1. So negative 5 is equal to a plus, oh, this is 0, minus c, right? Now, we know that a is negative 2/3. Oh, I could just substitute here because I already know a. So negative 2/3. So subtract, oh, I'm sorry, add 2/3 both sides. So negative 5 plus 2/3 is equal to negative c, right? So negative 5 is negative 15 over 3. So this is negative 13 over 3 is equal to negative c. So what is our c then? So c is equal to 13 over 3. Yeah. So c is 13 over 3. Good. Now, the other one, we will just choose x equals to 2. So we choose a simpler number. Yeah, small, simple numbers. So then when I substitute here, I have 3 times 2 minus 5. So 6 minus 5, that's equal to 1, is equal to a times 2 squared, so 4 plus 2 plus 1, plus b times 2 plus c times 2 minus 1 is 1. So we have 6 minus 5 is 1 is equal to 7a. Oh, 7a. I know a is negative 2/3 plus 2b. What is 2b? Oh, 2b plus c is 13 over 3, multiplied by 1. Okay, so it's just 2b plus 13 over 3. Yeah, so here I substitute the value of a. So a is negative 2/3, and substitute the value of c. C is 13 over 3. So 1 is negative 14 over 3 plus 2b plus 13 over 3. Okay? Now, if we don't want to deal with fractions, we will just multiply both sides by 3. So both sides is the same as each term, by 3. So here the 3 cancels, here the 3 cancels. Okay, so we're left with 3 is equal to negative 14 plus 3 times 2b, so that is 6b plus 13. So 3 is equal to negative 1 plus 6b. So we add 1 both sides. 6b is equal to 4. Divide by 6 both sides. b is equal to 4 over 6, which is 2 over 3. All right. Now I have very little space to write the answer. Okay, so I'm going to write it here. So what's my answer here? So a over x minus 1. So a is negative 2/3 over x minus 1 plus bx plus c. So 2/3 x plus c. C is 13 over 3 over x squared plus x plus 1. Okay, is there another way to write this? Well, yeah. Or this is okay, or you could write it as negative 2 over 3 times x minus 1. Plus, well, the denominator is 3, 2x plus 13 divided by 3 times x squared plus x plus 1. Okay, so either way should be fine. Yeah. All right. Now, case 4. So this is an example of case 3. Yeah. Now, case 4 is quadratic and repeated. Okay. Let's see here. All right. Let me see. Give me a second. I'm looking at it. Case 4. Okay. So I think we will do 2 examples of case 4. Yeah. Okay. Let me see. Okay. Sure. So case 4. So next page. Yeah. So case 4. Q of x contains quadratic factors some of which are repeated. Okay, so some of the quadratic factors are repeated. What do I mean by that? Yeah. So for example, if we have x cubed plus x squared divided by x squared plus 4 squared. Now, by the way, if the degree of the numerator is greater than the degree of the denominator, we have to do either sympathetic division or long division first. Yeah, I didn't mention that in the beginning, but if we have degree of numerator which is greater than degree of denominator, then we need to either do long division or sympathetic division. Yeah. So what is the degree of the numerator? It's 3. What is the degree of the denominator? It is x squared squared, so x to the 4, so the degree is 4. So we do not need to do long division here. Okay. Now, anyway, we have x cubed plus x squared and then x squared plus 4 squared. So we are going to write these as, this is quadratic, x squared plus 4, and then repeat it. So we have to write it twice, x squared plus 4, and also x squared plus 4 squared. Yeah, we have to repeat it twice. All right. Okay. All right. Let's see here. When x is equal to 0, sorry. Now, what goes on top? What goes on top is, this is quadratic. Yeah. So what goes on top is linear, ax plus b. And what goes on top here is also linear. This is quadratic, so cx plus b. Okay. Now this ax plus b, let's get rid of the fraction. So multiply by the LCD, which is x squared plus 4 squared. And then here we have x squared plus 4 squared. And here we have x squared plus 4 squared. And let's cross out something. Oops, actually I was wrong. On this one, I'm only crossing out one term, right? Because you have x squared plus 4. And here, you're crossing out the whole thing. So then we have x cubed plus x squared is equal to ax plus b multiplied by x squared plus 4 plus cx plus d. Alright. Oh, there's no need to put parentheses here because we cancel out the cx plus d. Alright. Now, We could choose a few numbers as usual, but we could also use method 2. Let me see. We have four variable, and that is what is that? That is A, B, C, D. Okay. And let's see, what C should we choose? What X should we choose? If we choose X equals 0, then we will have B and D. If we choose X equals 1, so anyway, we probably had better off use method 2 here, or you could use a combination of method 1 and method 2. It doesn't matter. But let's just choose method 2 here. So method 2, and then let's see what happened. We distribute, okay? Distribute and then equate the coefficients. Alright. So let's distribute. Collect like terms. So FOIL, ax cubed plus 4ax, so first, outer, inner, and then last. Last is plus 4b plus cx plus d. Okay? So this is method 2. We distribute. Yeah, ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. Now we're going to collect like terms. So x cubed, which one's my x cubed? My x cubed is just my a. My x squared is just my b. And then I also have, let's see what else here. X, which ones are x? So this is 4a plus c, right? And the constant we have, let's see, 4b plus d. So this is the constant. Let's check again. Ax cubed, so x cubed is only a. X squared is only b. This is 4a. X is 4a plus c. And then constant is 4b plus d. Alright. Now let's equate the left and the right. Yeah. So let's equate the left and the right. So what is the coefficient of x cubed here? Is 1. So now I only have a here, and this is 1 here, which is not listed. It is invisible. So then we have a is equal to 1. Okay? Just by equating this coefficient. Now let's look at coefficient of x squared here. This is b. And here, this is 1. So we know b is equal to 1. Okay, so actually method 2 is actually not bad either. Yeah. So you can always use method 2, or sometimes method 1, sometimes method 2. Now the next one, x, coefficient is 4a plus c. There's nothing here on the left. Yeah. So what we're going to write down is 4a plus c is equal to 0. Now I already know the a. A is 1. So 4 plus c, so a is 1. When we substitute, we have 4 plus c is 0. So c is negative 4. Okay. Good. Now, the last one is the constant, 4b plus d on the right. And what about on the left? No constant, so 4b plus d is equal to 0. Now, we know that b is equal to 1. So 4 plus d is 0. So d is negative 4. Yeah? Ooh, so look at this. Method 2 actually works also. Yeah? So we could label this as equation 1. This is the second one. Well, I don't label a equals 1 and b equals 1 just because they're solutions. Yeah? So we have all a, b, c, d. Now we could write our answers here. So the answer would be, okay, well, what's on the bottom here? X squared plus 4, so ax plus b So ax plus b over x squared plus 4. And then the other one is x squared plus 4 squared. So what is ax plus b? Ax, so this is, look at this. This is ax plus b. So 1x plus 1. So it's just x plus 1. Okay. Now the other one is cx plus d. So negative 4x minus 4 cx plus d is negative 4x minus 4 over x squared plus 4 squared. So actually we could rewrite these as x plus 1 over x squared plus 4 minus 4x plus 4 over, so this minus sign is actually distributed, distributed through 4x plus 4 over x squared plus 4 squared. Yeah, so either one would work. Okay? Alright. Now I'm done with all cases, but let me do one more. Let me do one more of maybe case 4. Okay. I was trying to see if we have something in which we have to do long division, but no, it's fine. So anyway, let's do more case 4. Yeah. All right. Let's see what this is. Okay. So case 4, more case 4, one more problem. Okay. So let's go to the next page. So one more problem, the last one. Number 2. What about if we have 6x squared plus x plus 1 divided by x squared plus 5 squared? Alright, now let's see, the exponent on top, the degree of the numerator is 2, the degree of the denominator is 4, so it is x squared squared, so that's 4. Okay, so now we will rewrite the partial fraction as x squared plus 5. This is quadratic, repeated. Okay, so x squared plus 5 squared. And what goes on top? Well, this is quadratic, so it's 1 degree less, so ax plus b and cx plus d. Okay. Now, get rid of the common denominator. So multiply both sides by x squared plus 5 squared. So we multiply by x squared plus 5 squared. Oh, this one put parentheses, x squared plus 5 squared. Okay, now cancel like terms. So this cancels everything. Yeah. Oh, here I only have x squared plus 5, so only the square cancel. We still have 1 x squared plus 5 term on top, and we also have x squared plus 5 squared on the bottom. Yeah, so we're left with 6x squared plus x plus 1 is equal to ax plus b times x squared plus 5 plus cx plus d. Oh, this cancels, so again I don't have to put parentheses here. Yeah. Let's see, if I choose x equals 0, this will be 0, and we still have b and d. Yeah. So maybe use method 2. Yes. So method 2. What is method 2? We distribute, collect like terms, and then equate the coefficients from left to right. Collect like terms, and then equate the coefficients. Meaning the left one has to be equal to the right coefficients. Okay? So let's see, 6x squared plus x plus 1. So when we distribute, what do we have? FOIL. So ax cubed plus outer is 5ax plus inner is bx squared plus last is 5b plus cx plus d. Okay. Now, we are going to collect like terms. So which one's x cubed? X cubed is just a. Which one's x squared? X squared is just b. Which one's x? Oh, we have 5ax and cx, so 5ax plus cx. So we factor out the x. And the constant is, which one? 5b plus d. Alright. Good. Now let's see here. Okay. We're going to equate coefficients. So x cubed on the right. Do I have x cubed on the left? No. So what does it mean? A is equal to 0. Because why? Because I don't have x cubed on the left. So here ax cubed, a must be 0. Yeah, and I box this. Now b, x squared. Do I have x squared here? Yes. So b is equal to 6. The coefficients must be equal. So b is equal to 6. Alright. Now, do we have x? Yes. What is the coefficient of x on the left? 1. What is the coefficient of x on the right? 5a plus c. So 5a plus c is equal to 1. So I'm going to call this equation 1. Yeah. But I know that a is 0. So this will be 0 plus c is equal to 1, which means c is equal to 1. Right? Alright. Now the last one, constant. So constant on the right is 5b plus d. On the left it is 1. So 5b plus d is equal to 1. Okay, so this is equation 2. But we know b is 6. So b is 6. So we have 5 times 6 plus d is equal to 1. So 30 plus d is equal to 1. So subtract 30 from both sides. D is negative 29. Alright? D is negative 29, right? So then I could write my answer. So supposedly ax plus b over x squared plus 5. So what is my a? Oh, a is 0. So it's 0x plus b, so it's just b. So 6 over x squared plus 5 plus cx plus d, which one's my c? Cx plus d over x squared plus 5 squared. So c is 1, cx plus d, so x minus 29. So 1x minus 29 over x squared plus 5 squared. Alright. So anyway, we're done with the, what is it called? We're done with partial fraction decompositions. There are 4 cases. So case 1 is linear, non-repeated. So case 2 is linear with some factors repeated. So remember, for linear repeated, you have to repeat those maybe 2 times or 3 times depending on the exponent. Most likely it's the exponent is 2, so we have to repeat it 2 times. Now, case 3 is partial fraction decomposition where the denominator contains some quadratic. So quadratic, remember? So when you have quadratic and non-repeated, the numerator should be 1 degree fewer. So it's going to be quadratic. The numerator will be linear. So it's ax plus b, right? So it's linear and constant. So ax plus b. So ax plus b is linear plus the constant. And if it is repeated, remember that we have to repeat it either twice, most likely twice. Yeah. If it is x squared minus 3 cubed on case 4, then you have to repeat it 3 times. Okay. So anyway, if the exponent or the power of the numerator is larger than the power of the denominator, you have to do long division first. Yeah, and then we will just do partial fraction decomposition on the remainder. Yeah, okay. All right, so I am going to conclude the discussion of partial fraction decompositions now. So please remember all those 4 cases and the way we are supposed to write it in the beginning. Yeah, and if you remember and we put everything correctly, then we could easily solve using either method 1 or method 2. Yeah, so method 2 is easy also. Okay, so we distribute, we collect like terms, and we equate coefficients. Method 1 is simple too. We choose some x's. When we choose a particular value of x, a few variables might be eliminated, so make it easy on the calculation. So we just choose method 1 or method 2 based on what we think is easier. So sometimes method 1 is easier, sometimes method 2 is easier. Yeah, you could see from the last 2 problems, method 2 is easier. Okay? Alright guys, I guess I will see you sometimes during class, and I hope you can look at the sample tests, and also we will discuss some problems on the sample test during our class meetings next time. Okay? Alright, I am going to end the discussion now, and let me stop sharing. Yeah, so we're completely done with partial fraction decomposition. Yeah, which is from section, let me see, is it 10.5? Yes, it was 10.5. Okay? Alright, we'll see you next time.